That's a little extra. I would guess that a lot of us might think that we do something like this, because that's how we added them, right? We just added them with their, but that's wrong. That's not how we do it. There's actually a couple different ways to multiply vectors, and it's like that. It is kind of what I just wrote, right? You times A1, the first one with the first one and the other one, second one with the second one and the other one, except notice, is this a vector? Does it have the little, no, that ain't no vector. That's a scalar. That's just a number. So when you multiply two of them, you just get a number back out. Specifically, I should say, when you take the inner product or dot product, your book really likes to say inner product. I think inner product sounds nasty, and I think dot product is a lot better. So I'll probably say dot product a lot more, but I'll try and interchange them as much as I can. Your book also says dot product, but they like inner product more. I like dot product more because that's a dot. Makes more sense to me, doesn't it? You see a dot there? Inner product. Ooh. Dot. Dot product. So you definitely probably want to write inner product, dot product, that down. And you absolutely do actually want to write this next piece down. They're perpendicular if their dot product is 0. So maybe if you wanted to fast hand it, A dot B, or if the dot product A dot B is 0, then A and B are perpendicular, or if you're fast handing in math, that means perpendicular. Remember that from geometry? Oh, and you might be like, hey, who cares if they're perpendicular? Who cares about a dot product? A lot of us have physics, right? Have you gone over torque? Well, guess what? We can maybe tomorrow, but torque is a perpendicular vector outwards. So torque is a pretty big thing in life. And there's other things, right? It's not just torque, but that's like the main big one that we can think of. Anyone need more time?
Thank you for dumbing that down.
Oh, this? Yeah. I mean, I didn't really dumb it down. I just rewrote it kind of. And it technically goes the other way. If you have two perpendicular vectors and then dot product is 0. Okay. Example 1, find each inner product and determine if any vectors are perpendicular. Well, P is 714 times Q, which is 2, -1. So if we do that, we do 7 times 2, which is 14, or maybe I'll write the first one all the way out. 7 times 2, then we add 14 times -1. Oh, hey, that's 14 minus 14. That's 0. What does that mean? It is they are perpendicular. Oh, just a reminder, self-perpendicular means that they make like a little right angle here. Oh, you want to know another really nice thing about perpendicular vectors? They make right triangles with the resultant vector of whatever you do, right? We love right triangles. Oh, and if they're perpendicular, you can set them up into two components. Usually we do horizontal and vertical, but if they're perpendicular, you can just do their one direction and then the other direction. Yeah.
So how do we go from having multiplication signs between the two x, y to having a position?
Where?
Where you see, 7, 2,
oh, that's the definition of the dot product. I don't know what else to tell you. That's one of those. It is what it is. So yeah, that's why it's a little weird. Why I had that think session in the beginning, because it's kind of not intuitive to, right? You kind of just want to do 7 times 2 and then 14 times -1 and leave them in their spots, but it spits out a number, not another vector. It spits out a scalar. Okay. Hopefully I don't run out of room. P times M. P is 714 again. Times M is 35. We might have to do the other one. Yeah, we'll move this one down here. 7 times 3, 21, plus 14 times 5, 50 is 70. Is that right? Are they perpendicular? I don't feel like writing perpendicular out. Yeah.
So that's just what the focus work is like, bring up on a third perpendicular.
Yeah. Okay. And then if we're doing Q times M, then what was Q? 2, -1. 3, 5. Two times 3 is 6. Add, or it'll actually be minus. Are they perpendicular? No, because that thing's not 0. If that thing's not 0, it's not perpendicular. If it is 0, it's perpendicular. That's all there is to it. Any questions on this stuff? It's not too bad, right? Find the dot product of A dot B. Oh, we don't say A times B, by the way. You're supposed to say dot. Another reason I like to say dot product, because it's read A dot B. And we don't say multiply because there's kind of two different kinds of multiplication. So A dot B, and determine if the vectors are perpendicular. Uh-oh, we're in 3 dimensions. I didn't give you a definition or a formula for what to do when there's 3, but you guys can probably guess what we're supposed to do. All right. We're going to do the same thing. We're going to take -3 times 2. Then we're going to add 1 times 8. And then we're going to add 1 times -2. All right. So same thing as last time, except now we just have this third guy that we need to add when we multiply them. Right? -6 plus 8 minus 2. Oh! Whoa! What does that mean? They're perpendicular.